Everyone, we're looking at class number 14, and our goal is to use constant acceleration equations to predict the motion of objects. So the do now here is just looking at a question. It looks really complicated. Just take a second to read it. We got a ball rolling along a table. The table has a certain height off the floor. It takes a certain amount of time for the ball to hit the floor. It's asking for the magnitude of the acceleration, 0.2 seconds after it leaves the table. Neglect friction. Now you should realize that 0.2 seconds after it leaves the tabletop is before it hits the floor. So this ball is in midair. So the question is basically asking what's the magnitude of the ball's acceleration when it's in the air. And you know that any object on Earth that's relatively close to the Earth's surface and is in the air has an acceleration of exactly 9.8 meters per second squared. Doesn't matter if the ball is going sideways, up, down, left, right, whatever. If it's in the air and it's only under the influence of gravity, like no other friction or anything touching it, that's its acceleration, 9.8 meters per second squared downward. So we're going to use this equation a lot today. It's the equation acceleration equals change in velocity over time. Now, it's never written like this on the reference table, okay? But it's written in these two formats. A equals delta V over T, delta means change, or V final equals V initial plus AT. Now, those two equations are basically the same one, just rearranged. How so? Well, look at this delta V. Delta V means final velocity minus initial velocity. So I can rewrite this equation over here. A equals V final minus V initial over T. All right. Multiply both sides by T, and I get AT equals V final minus V initial. Add V initial to both sides, and I get V initial plus AT equals V final. Check that out, VF equals VI plus AT. So these are basically the same equation, okay? Just rearranged. And it depends on what you're looking for. If you're looking for A, maybe use this one here on the left, because A is already isolated. If you're looking for V final, use that one on the right, because V final is isolated. So this question says a 6 kilogram cart, so let's write down our givens as we read them. The mass is 6 kilograms. Initially traveling at 4 meters per second east. So we'll say east is positive. So initially traveling, so that's V initial. 4 meters per second, positive, right? Because it's east. Accelerates uniformly at 0.5 meters per second squared. So that's A. And that acceleration is pointing east, so the acceleration is positive. 0.5 meters per second squared. If you want to put the positive right here by the 4, that's fine too. Let's see, for 3 seconds, so T is 3. What is the speed of the car at the end of the 3 seconds? So for V final. All right, so since we're looking for V final, I'll use this one here, VF equals VI plus AT. VF equals, so substitute with units first. You got to write the equation, substitute with units. 4 meters per second plus A, which is 0.5 meters per second squared. T, all right. And then from, oh, nope, T is actually 3 seconds. So I know that piece of information. All right, so now I can solve through. These seconds here cancel with those seconds there, so I end up getting 5.5 meters per second. This is 1.5, this is 4, add the two together, 5.5 meters per second. A car with an initial velocity of 16 meters per second. So the initial equals 16 meters per second east, so we'll make east positive. All right. Slows uniformly to 6 meters per second east, so that's also positive. So that's our final velocity. Now, some people are thinking that that's the acceleration, but look at the units. It slows to 6 meters per second. It's not squared, so it's velocity, not acceleration, in 4 seconds. So what's our acceleration? So I'll use A equals delta V over T. Delta V is always V final minus V initial, always final minus initial. So it's 6 meters per second minus 16 meters per second. And that ends up being negative 10 on top. Negative 10 over 4 is negative 2.5 meters per second squared. Let's see, a car approaches a red light with a velocity of 24 meters per second, slows to a complete stop. So the initial velocity is 24 meters per second. The final velocity is 0 meters per second because it stops. Okay, stops means that the final velocity is 0. Our time is 3.2 seconds. What is the acceleration? So A equals delta V over T. Delta V is final minus initial, so 0 minus 24. Right, so negative 24 divided by 3.2 is negative 7.5 meters per second squared. Starting from rest, all right, so next one here, the initial is 0. A car travels 18 meters as it accelerates uniformly, so we don't know the acceleration, for 3 seconds. What is the magnitude of the car's acceleration? So for this one, I would have to use, let's see, I have T, D, V initial, I'm looking for A. I don't have V final, so I'd have to use this equation here. T equals V initial times time plus 1/2 AT squared. So D is 18 meters. V initial is 0 times T, that's doesn't matter what it is, it just goes away. 1/2 A and then 3 squared. All right. So 1/2 of 18, or excuse me, 1/2 of 9, okay, because 3 squared is 9, is 4.5 A. So 4 meters per second squared equals A. So this one's not review, but we've seen stuff like this before. So just like position versus time graphs or displacement versus time graphs, we have velocity versus time graphs. So the question is, what is the slope of the graph to the right? Just do rise over run. Doesn't really matter what you choose for your rise, what you choose for your run. I'll just switch up the color so it's easier to see. It's a triangle though, so why don't we let's just use the whole thing. So my run is going to be 5 seconds, and my rise is going to be 25 meters per second. Okay. So slope equals rise over run. Keep the units in, that's important. My rise was 25 meters per second. My run was 5 seconds. So it's 5 meters per second squared. So that's my slope. Now the question is, what does the slope represent? I just showed you. Okay, how did I just show you? Look at the units on the slope. Meters per second squared. So meters per second squared represents acceleration. All right. So there you have it. Slope of velocity versus time is acceleration. What's another way you can kind of know that? Well, remember, acceleration is the rate at which velocity changes. Does this show the velocity changing? I think so. It's getting bigger over time. It goes from 0 to 25. So the slope represents that change. So the slope represents acceleration. What is the area under the graph to the right? Well, for that, you would just do this highlighted area here. It's a triangle. So find the area of this triangle. How we do that? 1/2 base times height. So it's actually really similar to the last one as far as the numbers we're going to use. So area equals 1/2. The base is 5 seconds because it's a triangle. The height is 25 meters per second. Our seconds cancel. Multiply across. I should end up getting, let's see, 62.5 meters. All right. So that tells me, those units tell me that the area under velocity versus time graph represents displacement or like distance traveled, position, something like that. These are practice questions we didn't necessarily do in class. So it says the graph below represents the speed of a marble rolling down a straight a straight incline as a function of time. What quantity is represented by the slope of the graph? So it's speed versus time, very similar to velocity versus time. So we said the slope of velocity versus time represents acceleration. And if you really wanted to, you could find the slope, right? Rise over run. Look, pick 2 points. Let's see, 4 and 3 here. So it ends up being like about 1.3 meters per second squared. All right, how'd I do that? Rise over run. 4/3. Now number 20 says, calculate the distance the marble travels during the first 3 seconds. So I'll work including equation substitution with units. So there's a few different ways to do this. You can use equations here. You could use the equation like d equals v initial times time plus 1/2 at squared. A few reasons why I don't like doing that one. Yes, you know it's 3 seconds. Yes, you know the initial velocity is 0. But the acceleration there you'd have to find, which is about 1.3. Maybe you made a mistake there, but you could use that equation. This would be 0. This would be 1.3. This would be 3. And don't forget to square that 3. But there's another way we know how to do this, and it's using the area. So I can simply find the area up to 3 seconds. It's a triangle, right? So 1/2 base times height. So area equals 1/2. The base is 3 seconds. The height is 4 meters per second. And we get 6 meters. All right, that's your answer for this one. All right, and the last one here. A car initially traveling at 15 meters per second north, so that's our initial velocity, 15 meters per second. North will make positive, accelerates to 25 meters per second north, so that's our final velocity in 4 seconds. What is the magnitude of the acceleration? So since A is the one we're looking for, we'll use the equation that isolates A equals delta V over T. Delta V is final velocity minus initial velocity. So 25 meters per second minus 10 meters per second, all over 4 seconds. And you get 2.5 meters per second squared. All right, so there you have it. Let me know if you have any questions, and have a great day.